Hello scholars, welcome. Mr. Hinkle here to talk about geologic folds. So in this lecture we will define folds and then we'll look at the various types and categories that folds exist. So let's review. A geologic fold is a layer of rock that is bent or curved by ductile deformation. Deformation is the movement that results from regional stresses that can be elastic when the rocks reverse, ductile when the rocks bend or fold, and brittle when the rocks break or fall. Here we're talking about ductile deformation. They usually happen at depth in Earth's crust where we have higher temperatures, higher pressures, not so high that the rocks are changing, but high enough that the rocks can bend without breaking. And we see examples of these in big mountain ranges, the Alps, the Himalayas, the Scottish Highlands. As we see here, we have this fold that is basically really, really tight and then turned over on itself. We'll talk about all the different types here coming up. But first, the anatomy of a fold. So we have a limb on one side and a limb on the other. And then the plane that separates one limb from the other is going to be the axial plane. And a line, right, planes are different than lines, the line that basically is going to go right across in line with the axial plane is the hinge line, usually giving us a hinge zone where you can have associated faulting, not always, but usually what we have are fold and thrust belts where folds and faults are occur in unison together. But we're just talking about folds, so let's stay here. Fold limb, axial plane, hinge line. Great. So this gives us a few different types of folds. And right now we're looking at these four down here. We have symmetrical folds where the fold limbs are symmetrical amongst the axial plane. We have asymmetric folds where you have a non-vertical dipping axis and then slightly different angles for the beds on either side of the axial plane. We have overturned folds where you have a really steeply dipping axis and then the folds are dipping in the same direction but at different angles. And then, as we saw in our example on the last slide, we have a recumbent fold where the fold actually reaches near horizontal. Cool. So these four types of folds are seen all over the earth and they create specific fold structures. And the five that we're going to get into today are anticline, syncline, monocline, dome, and basin. So, anticlines, this is the way that I had always learned it. Okay, so we're going to say at time equals 1, we have sedimentary rock layers. Compressive stress is going to shorten and thicken these layers, causing them to fold. Remember, folds are when rocks bend and don't break. Now, I've drawn two features here. We could say that when the fold limbs are plunging down on either side of the axial plane, we have an anticline. And it's almost, you can make an A in the anticline. On the other side, now when the fold limbs are moving up relative to the axial plane, this becomes a syncline. You can't really draw an S in there. It doesn't make an S as well as it does an A. But the anticline and syncline. So features about the anticline, downward curving limbs. The older rock strata are in the center along the fold axis. So if this is the oldest layer here, and you bend the layers on either side, The oldest rock layer is in the center. Let's just do a big star. And then we move to syncline, its counterpart, where you have the opposite direction of the angle of the beds dipping for the fold limbs, and now you have the youngest layer in the center. So again, if we're trying to figure out geologic history, sequence of events, we've got folds, where are they oriented, which layers are older than the others. We can use principles of stratigraphy and our knowledge of geologic structures, in this case geologic folds, in order to understand which came first and which came later. Okay. Anticlines and synclines. So here is a much better drawing. Oldest layer, it's on the bottom. Youngest layer, it's on the top. Got it? We can see in real life, we have a syncline and an anticline, and then there's surface erosion that has lopped off the top of the rocks. What if there's only one fold limb? What do we call that? Well, one, single, mono. Monoclines are step-like folds where flat rocks are bent either up or down. We can see they're bent in one direction here. This real-life example has them going the other way. This usually happens when you have a fault dragging layers. So again, faults and folds, brittle and ductile deformation working in harmony together. Our Earth is complex and amazing and beautiful. Domes. So this is an actual photo of a dome. And the thing about a dome is we need to go a little bit 3D. I wish I had a piece of paper and had thought about this, but I'll be right back. So faults and folds happen when an anticline folds layers, something like that. Or a syncline folds layers like that. But there's often times where you can have intrusions where the folding down is going to be in 3 different directions. And this is going to be called a dome, an upwarping of the rocks. Here you can see the rocks are warped up on each side, and then you have erosion showing the concentric layers. It's kind of like a bullseye pattern that we see here. The youngest layers are on the outside, the oldest layers are on the inside. Now this contrasts to basins, where you have the opposite. You have a down warping on all 4 sides that we could see here. So now the layers are down warping. But what you get is the youngest layers on the outside and the oldest layers on the inside. So it's exactly opposite. Here we see a real world example of a dome, very strong layers that are surrounding it. So, dome, oldest in the center, youngest on the outside. Basin, youngest on the outside. Youngest in the center, oldest on the outside. So they're opposite of one another. Geologic folds are structures created from regional stresses because of plate tectonics. And they reflect ductile deformation where the rocks bend and they don't break. They come in lots of different shapes and sizes, symmetric, asymmetric, recumbent, overturned, creating various structures, anticlines and synclines the most common, but also monoclines, domes, basins. This is a brief introduction. There's other nuanced, specialized types of folds out there, which if you continue your studies in structural geology, you will learn more about. But this has been our intro to geologic folds.